Picture this, you're a technical artist staring at an Unreal Engine project that won't compile. You need one C++ helper, one Niagara system spawn, and a clear reason for the editor warning. You ask an AI model for help, and it gives you a paragraph that sounds confident, almost right, and then breaks your build. That moment is where the real difference between Kimi K3 and Claude Code starts to show. I'm with MonsterPixel Labs. If you're new here, we break down what's actually happening in Unreal Engine and gaming tech and what it means for your work. If that's useful to you, hit subscribe and drop a like. It genuinely helps this channel reach the people it's for. To understand this comparison, separate two things people often blur together: a model and a coding agent. A model is the brain. It reads text, code, logs, maybe screenshots, and predicts what should come next. A coding agent is the body. It can open files, edit them, run terminal commands, call tools, and loop until the task looks done. Claude Code is built around that agent idea, working in your terminal, IDE, Slack, or web surface. Kimi K3 is a different entry point, an open-weight model from the Kimi platform with 2.8 trillion parameters and a 1 million token context window. You can use it through an API or run it on your own infrastructure once the weights are available. So when people ask which is better for Unreal Engine, the honest answer is they're not the same category. One is a powerful brain with tool support. The other is a packaged workflow around that brain. Here's the part that matters most for game development: context. Imagine a fast junior developer who can read code and run builds, but only works with what you put on the whiteboard in front of them. The context window is that whiteboard. One header file and one compiler error, they can help. The entire project, their notes get messy, the cost goes up, and the answer can drift. Kimi K3's 1 million token window is a big whiteboard. Claude plans commonly list around 200,000 tokens. That doesn't automatically make Kimi better. A larger window can hold more files, but it can also dilute focus. The skill is still curation. Which source files, which logs, which screenshots, which constraints belong in the request. Now let's make it concrete. Suppose you need a C++ function that spawns a Niagara system on key press, plus a blueprint-safe fix for a compile error. With Claude Code, you open the terminal or IDE, point it at the relevant files, ask it to fix the error, and let it propose edits and run commands. With Kimi K3, you send the same files through an API, include a screenshot of the editor error, ask for a JSON plan with edits and build commands, and let your own pipeline execute it. The difference is architectural. Claude Code feels like a coworker sitting next to you. Kimi K3 feels like a model you wire into your own tools. That wiring has a cost. Kimi K3's API pricing is $3 per million input tokens, $15 per million output tokens, and 30 cents per million cached input tokens. If you reuse the same project context across requests, that cache discount can matter. Claude's API pricing varies by model. Sonnet 5 is $2 per million input tokens and $10 per million output tokens. Opus 5 is $5 input and $25 output. But Claude Code is often used through plans, sometimes up to $200 a month, so your limits may be governed by subscription usage rather than a simple token meter. Kimi also has membership tiers with effective monthly prices from $15 to $159. Don't pick the cheapest sticker. Understand what you're buying: raw model access, agent convenience, context length, tool calling, visual input, rate limits, and how your studio will verify the result. This is where Unreal Engine changes the game. Unreal work isn't just text files. It's C++, blueprints, Niagara, asset references, build output, and performance budgets. A model can be excellent at reading code and still fail at the visual, binary, or project-specific parts. That's why community reports about AI assistants struggling with blueprint modifications, rate limits, and context constraints are so useful. Coding ability doesn't equal engine mastery. The model can propose a change, but the technical artist still has to run the build, check the Niagara spawn, and confirm the pipeline didn't break. So what should you do? Test both in a narrow, repeatable task. Maybe it's fixing a compile error, reporting on a Niagara parameter, or writing a helper that connects input to a particle system. Run the same request through Claude Code and through Kimi K3. Measure 3 things: quality of the fix, cost of the request, and how much manual cleanup you had to do. If your pipeline is local and security sensitive, Kimi's open weight direction may be attractive. If you want a fast integrated terminal and IDE workflow, Claude Code may fit better. For VFX, visual effects professionals, these tools are becoming part of the production coordinator role. They can patch scripts and call departments, but the director still approves the final cut. The lasting idea is simple: don't choose an AI model by benchmark alone. Choose it by how well it fits your Unreal Engine workflow, your verification process, and your cost model. A 1 million token window is impressive, but it's not a substitute for a clean task. A polished coding agent is powerful, but it's not a replacement for a technical artist who understands the engine. The best setup is hybrid. Use the model that gets you closest, then keep the human loop tight. Keep an eye on how open-weight models like Kimi K3 land in production pipelines. That'll tell us a lot. Before you go, if this was useful, take a second to hit like and subscribe. That support is genuinely what keeps this channel growing, and it's what lets us keep digging into this stuff properly. Anyway, that's the briefing for today. See you in the next one.